All right, welcome to my first video, Mr. P's homework help. This is kind of going through to check the homework together and kind of show you what maybe we were doing wrong, maybe we're doing right. Hopefully we're doing it right. So again, this question asks, name the types of quadrilaterals that seem to have each of the following properties. The diagonals are equal. So we can take a look at some of our options. Got like squares, rhombus, rectangle, all that stuff. So let's look at trapezoid. Are these diagonals going to be equal? Let's draw some on here. Maybe not, right? Because in this case, those diagonals are not going to be equal. In a rhombus, maybe not, right? Doesn't seem like they'd be equal. Square, definitely, with those 90-degree angles. I think those diagonals are going to be equal, and I think that same thing with a rectangle. So I'm going to go square and a rectangle for this question. Next question says the diagonals are perpendicular to each other. So for this question, we're going to take a look again at our pictures. With the trapezoid, that doesn't look like really like a 90-degree angle in either case for me. Rectangle doesn't really look like that either. Honestly, this one looks more obtuse, and maybe this one a little bit more cute. So maybe not with a rectangle either. If we take a look at a square, that's definitely looking like a 90-degree angle, like it's a perpendicular diagonal. And same thing with a rhombus. Looks about like we've got a 90-degree angle intersection there. So I'm going to go square and rhombus. The next one says the diagonals bisect each other. Bisect meaning cut into two. So thinking about this question, I'm going to look at all my options. Looks like the rhombus, I would say yes, although the diagonals aren't equal. I'd say that they bisect each other. They cut each other in half. Trapezoid, I'm gonna go no. They don't really look like they cut each other into equal parts. Square, definitely yes. Parallelogram, looks like they do. Looks like these two sections are definitely equal to each other on either side of the intersection. Rhombus, I'm gonna say yes. I think we already talked about that one possibly. And what about rectangle? Rectangle, I'd say as well. Looks like the big thing here is that if they meet in the middle, mine aren't drawn perfectly, but looks like that intersection is in the middle. Same thing with a parallelogram. So I'm gonna mark down square, rectangle, rhombus, and parallelogram. Oops, two A's. Parallelogram. All right, for 17 to 21, we're gonna have to use our knowledge of the quadrilaterals and that they have an angle sum of 360 degrees. So we're trying to find this one missing angle. We can take 360 and subtract from that each of these parts. And we get, when we do that, we get 68 degrees. This one is 68 degrees. 19, same thing. We're trying to find this exterior angle. We don't know how to find that using these interior angles, but we do know how to find this angle, and then we can kind of figure out what that exterior angle is in a second. So let's go ahead and subtract off the parts. 76, 115, 102. When we subtract all those off, we get 67 degrees for our inside angle. That's not our final answer. We also know that this interior and exterior angle are a linear pair. So this one has to be 113 in order for 67 and 113 to add up to 180. So our final answer is 180. I think I skipped 18. Coming back to 18, we see that this is a right angle, this is a right angle. We know those are equal to 90 degrees respectively. So we can take our sum 360 minus 90, minus 90, minus 64. Let's scoot that back over. It's not in the way of the other one. Maybe shrink it down over there. And that is equal to 116 degrees. Oops, a little thick on the pen there. 116 degrees. So that's our final answer there, 116 degrees. Number 20 asks us to find this missing angle here. And you're asking me, Mr. P, we only have two of the four angles. There's no way we can find those. Well, good thing we have knowledge of same side interior angles. That's the trick with these. same side interior angles. That's actually going to come up a lot in the rest of the homework. So we know that these are parallel, and we know that these are transversals. Okay. So which are our same side interior angles? I would argue that 53 and this arrow are same side interior angles. So using this transversal I'm drawing right here and these two parallel lines, let's go ahead and figure out what do same side interior angles have as a sum. You're thinking about that? Well, you remember 180 is their sum. So if I subtract 53 from 180, I will find that this is a 127 degree angle, and that is your final answer. 21 asks us for this angle here. This is really talking about this large, looks like a parallelogram, looks like a rhombus actually too, split into two equilateral triangles. So what do we know about equilateral triangles? That's something we learned from last semester and last year, I guess. Each of these is 60 degrees, right? That means this one is 60 and this one is 60. We're looking for that, both of those kind of combined. That makes that total angle 120 degrees. 22, we've got a parallelogram, right? Both sets of opposite sides are parallel. So we have a bunch of same side interior angles. Like I said, it's going to come up. It's going to come up even after this problem. So like this one and this one are same side interior angles. This one and this one, this one and this one, this one and this one. They're all same side interior angles with respect to each other. So we know this is going to be 110 degrees. This will also be 110 degrees. And we can finally surmise that this one has to be 70 using that information. Because this has to add up to 180, this has to add up to 180, this has to add up to 180, these have to add up to 180. They all have to add up to 180 because they are same side interior angles of parallel lines. Right. Quadrilateral bolt, B, O, L, and T are all equiangular. We know it's a quadrilateral, so it has to add up to 360. Okay, so if we divide that by 4, that's how many angles we have. We get 90 degrees per angle. Okay, so if we have if we have 4 90-degree angles, we don't know anything about the sides necessarily. We know that this is a rectangle. We can conclude that its angles are 90 degrees or right angles, right? That's what we just calculated. And that brings us to 28. It says, y is AN parallel to BD. So we're given that AN here is perpendicular to ND, and so is BD. So again, we're thinking same side interior angles. So how do we know AN is parallel to BD? Because angle N and angle D, you can see those on the picture, are supplementary. And same side interior angles. I'm just going to write the shorthand. So AN must be parallel to BD. Remember, there's a few ways to prove that a set of lines are parallel. One way is to show that the same side interior angles are supplementary. Another way is to show that the alternate interior angles are congruent, all that good stuff. But for this one, it is showing that the same side interior angles are supplementary. What kind of quadrilateral, using that information as BA and D, we can mark that these are parallel now. So we have two sets of parallel sides. We don't know anything about the other side lengths. We only have two 90-degree angles, so those don't help us. So I would say that this is a trapezoid. Lastly, 30 says, what are angles A and B called with respect to transversal AB? So that's angle here and angle here. Again, thinking about same side interior angles. Those look like same side interior angles to me. Same side interior angles. And last question, why are A and B supplementary? So we know that they're same side interior angles. We know that AB, which is right here, and BD are parallel. So we can say since AB is parallel to BD and angle A, comma angle B Ooh, B, try and B, there we go. B are supplementary. Oops, not that they're supplementary. And A and B, angle A and angle B are same side interior angles is what I meant, right? Then we know angle A, angle B are supplementary as well. Yep, supplementary. Okay, so I hope this was helpful on your homework. Check in that. Thanks for watching, and that is all I got for you.